Okay, so this is quadratics number 2. We're back to algebra with quadratics number 2. The title of quadratics number 2 is Multiplying Binomials. What's a binomial? It's like a bicycle, right? How many tires does a bicycle have? So the binomial has 2 terms. Thank you very much, 2 terms. And the terms often will look like this. Let's start with the one they give on the board. X minus 7, negative 5x minus 6. All right, 2 terms. This is one, term number 1, term number 2. All right, so that's a binomial. We could also call it a polynomial because it's more than one term. What's happening between the 2 parentheses? There's an operation in math going on here. It's invisible. What's happening between there? What's the operation between these 2 parentheses here? Yes, and remember in math, operations, I guess you could think like a surgeon. The surgeon does different operations, right? I don't know, heart transplant, I don't know what comes to mind. I don't know that many surgeries, I guess. So in math, you have operations, and your operations are addition and its opposite subtraction, multiplication and its opposite division, power and its opposite root. In this case, we'll do multiplying binomials, and we'll do factoring. That's a forward and reverse, basically a multiplication and a division process, but expanded a little. All right. In the United States, we teach this thing called FOIL. Other countries don't teach this because I've had students that have learned math from elsewhere, and they come in and go, what the heck is FOIL? Basically, it is a distributive process. We're distributing or multiplying across terms in the parentheses. Anybody remember what F stands for? First, good. O? Okay. Nice, thank you, thank you. I?
Inside.
All right. And L?
Right.
And as fun as this word is, FOIL, I don't know how helpful it is. It's a little bizarre, right? In the kitchen, we use foil. What do we use foil for? To wrap up leftovers, right? Aluminum foil. So I don't know what it's got to do with math. It's just a word that it spells, right? Foil. It's first, outside, inside, last, which is an acronym. That's not always clear to students. If you look at this thing and you say, what's first? I don't know that my brain knows. My brain goes here for first. Okay, but what they're doing is going, this is one term, this is another, and there's sort of this center line right down the middle there. So two sort of sides, left and right. So this is the first of the first term. This is the first of the second term. So we're going to multiply those together. That's the first terms of the 2 binomials, right? Outside, a little bit weird because you have to sort of think center out. And if your brain's not looking at it that way, I'm not sure what outside means, but it's the ones furthest out toward the outside, I guess. It's kind of clear, maybe. Okay, so you're going to multiply those. Then we're going to do the inside terms. If these were the outside, these are the inside terms. And I think in the beginning, while you're calculating these, you should draw these arrows. Okay, last would be if these were the first, those got to be the last. You're going to take into account signs. So, you know, when you multiply this negative 7, it's going to be multiplied by a negative 6. So you're going to follow the negative multiplication rules. Then there's going to be a combining of like terms in this where we add like terms. That's going to happen. So a pretty complicated process until you practice it a few times. Now I ask you to load PhotoMath on your phone. Is yours loaded? Did it load? And did you say open? And is it ready to go? It gives you a little tutorial. So my camera's being used for this, so I'm using her phone. This is what it looks like, right? There's a window. And all you do is take this thing, even before we get started. I don't know if it'll do it given all my... Do I have to tap it? Do I have to say this? What do I have to do? And now it's giving me a whole, it says multiply the polynomials using algebra. It gives me a whole lesson. Show me. And it calculates it out. There's the answer already. It'll show you all the steps. If you click this, it'll show you every single step I'm about to show you. This is like having a teacher in your phone, right? You can do this without me standing here walking you through it, which if you're at home trying to do a homework problem and or you're trying to solve something that you have a question about, I think you definitely need to use the technology. So you keep this and let's see if we get the right answer, all right? Okay, so let's go through multiplying first. X times a negative 5x, and this can be a little bit complicated until your brain gets back into gear. It's a negative times a positive, so it's a negative. It's a 5x times an x, so I think it's 5x squared. Am I on track so far? I got a negative 5x squared. Okay, nice. Let's do outside negative 6 times x is a negative 6x. Let's do that inside now. Negative 7 times negative 5x. Negative times negative is positive. 7 times 5 is 35. And there's an x on this one, so it goes with it. And so you see my brain kind of trying to do one thing at a time, right? There's a lot, even though it's just pretty, I guess it's simple, but there's a lot going on here. So my brain's trying to separate, what can I do first? What can I do next? Don't forget that. Negative 7, negative times negative is a positive. 6 times 7 is 42. Now this doesn't look like their answer yet, right? Look at their answer. Because there's like terms right here. This is a negative 6x and a 35x. That's, remember CLT? What's CLT stand for?
Combine like terms.
Yeah, combine like terms. Remember that. So, strangely enough, all 4 steps up here, by the way, why do I call it a quadratic? Because there's 1, 2, 3, 4 multiplication steps that produce this power. It's a little bit weird, but always when I was a student, I'm like, it's raised to the power 2. Why are you calling that a quadratic, right? It's the idea that it's the area of a square, and I always look at it like it's 4 multiplication steps, right? Maybe a little bit off topic from the actual answer, but it got me through understanding quad being 4 and why this thing's called a quadratic with a power 2 on it. So first we did multiplication 4 steps. Now all of a sudden look at this. This is not multiplication. This is addition or subtraction. So the rules change around this. They need to be like terms, both being an x. So there's 35x's minus 6x's. I think I'm down to 29x's. I've still got the 42 on the tail. I often call that the tail. And I've still got the lead term of 5x squared. This became positive because it's the larger number. 35 minus 6. I think I'm at 29. Does that look like what they got? Once again, if you click that red button right under the answer, look at the steps they show you. They're going to show you this. They're going to show you multiplying. And for each of the steps, you can then click on the step, like click on this step. There you go. And it shows you even more. And I think there's even an explanation. So it keeps getting deeper for you. If you know enough to just roll through it and you want to know the answer, it shows it to you. If you want to keep saying why, the app allows you to keep asking why. Yeah, do I feel intimidated that I've been replaced by a machine? Of course I do. Yes, I am on the way out the door, right? At the same time, you're being exposed to technology. That's awesome. Why would we not use it, all right? If your teacher's telling you don't use it on a test, fine, I get it, all that stuff. But in the meantime, when you're studying something, use all the technology you can get to figure it out, right? What an awesome experience that you have even this opportunity to do that. So first, outside, inside, last. Now is just binomial, distribute. So what is the distributive property? Let's cover that quickly. We're using it in FOIL, but it's kind of hidden. Distributive property. Okay, so the example in the notes is simple at first. 5 times x plus 3. Say we have a 5, it's times x plus 3. Distributive is the idea that the 5 needs to get multiplied by the x, and the 5 needs to get multiplied by the 3. That's what's happening here in FOIL. But if you think about another way, so what happens? 5 times x is 5x. 5 times 3 is 15. This is the expanded or distributive view of this expression. There's a reverse of this called factoring, which is like the division process. Factoring, right? And that's where you look at both terms and you go, hey, there's a 5 here and a 5 here. I'm going to pull it out front. 5x divided by 5 leaves me with an x, and 15 divided by 5 leaves me with a plus 3. So here I went forward like a multiplication step, and then here I'm going backward like a factoring step. So an expansion of multiplication and division. We were here, we multiplied to get this. If your brain is thinking forward a little bit, guess what next lesson is? You're going to take this and go backwards back to this.
Because I was doing the factoring one, and I wasn't getting it, and so I reversed it.
Yeah, well, I mean, go back to the whole addition versus subtraction. Which was easier for you, addition or subtraction?
Addition.
Which was easier for you, multiplication or division?
Mine.
Well, so I always say it's like walking forward is the forward direction, and that's easier than walking backward. I can walk backward, but it's a little bit harder. I can't see where I'm going. I can't walk as fast. My flip-flops fall off. Right? Different complications to going backwards. So you can see how multiplying looks a little bit clearer to me, but now this starts to get a little bit hazy in my mind, where this is a more difficult process going backwards. Okay? So we've used photomath, we've done CLT, combined like terms, we've used FOIL, we've talked about distributive, we talked about quadratic, why does it have 4 in it? And let's do one last thing. Let's show how the FOIL method, being these 4 steps and this first outside, inside, last, which we like a lot, if you came from some other part of the world other than the US and they taught you how to multiply this, they would have done it in a distributive fashion. So see how the x got multiplied by both terms of the second. So you take the first term, the first, our first, well, it looks like this. I can't talk, okay? The x comes out here, multiplied by the second, negative 5x minus 6. There's a subtraction going on in here, right? Minus 7, and it's being multiplied by this, negative 5x minus 6. So notice we dismantled the first term into its 2 pieces, x and minus 7, and we multiplied them separately by the second binomial in independent steps. What happens, just like with distributive, this gets multiplied here and here. This gets multiplied here and here. Notice, x times negative 5x, x times negative 5x, that's happening, check. X times negative 6, that's happening, x times negative 6, check. A negative 7 times a negative 5x, negative 7 times a negative 5x, check. And a negative 7 times a negative 6, negative 7 times negative 6, check. So that's the 1, 2, 3, 4 multiplication steps of FOIL, but shown in a distributive fashion of the way you would set it up if you did it using the distributive property. So this is using the distributive property. It's just some sort of slick way, and I don't know how it got so pervasive in our culture that we teach this FOIL method, but across the country, we teach FOIL. So, and then if you multiply this out, we'll do the same thing. Negative 5x squared, negative 6x, negative times negative is positive, 35x, negative times negative is positive, and a 42. Combined like terms, 35 minus 6 is the 29x, the 42 is still on the tail, and the negative 5x squared is here, and this became positive because the larger one was positive. And I'm curious, do you still have your photo math up? Do a new window. Let's take a picture of this right here, and it'll generate the same thing. Photo math is, man, they've made it smart. All right, so big, I gotta pull back. Oh, you do it. Here, sit there and see if you can, it's just about, and push the red button. And negative 5x squared plus 29x plus 42. Oh, right? So your photo math is smart enough to figure it out in whatever format it's in. It'll multiply it in this format, it'll multiply it in that format. Very cool. In engineering school, I was one of the first students, my class was one of the first classes, and I was one of the first students to have a graphing calculator in engineering school. It was awesome. In differential equations, we could graph the differential equations. I don't even know if the professors knew we were able to do that yet, right? So there were no rules or anything of no calculators, and it was a lot of fun. It was actually a lot quicker to be able to see results of math. It's just like with Desmos, when you can type in 3 or 4 different graphings and it graphs them for you, and you get to compare them. It's much better for your brain to look at. Your brain likes that so much better. Okay, so let's stop this lesson and let's roll straight to the next one.